Welcome to the factory floor where one of the world's most powerful forest machines begins to take shape. The John Deere 1470G's story starts in the steel shop, where raw plates and billets are transformed into the backbone of the harvester, the chassis. Massive hydraulic presses reshape heated steel, while CNC centers mill precise mounting points and tolerance surfaces. Welding booths manned by skilled technicians and robotic arms fuse sections together in carefully sequenced passes, balancing heat input to prevent distortion. During each step, inspectors verify dimensions with laser trackers and coordinate measuring machines, ensuring alignment that will determine the machine's durability and handling in rough terrain. As the chassis emerges, integrated hardpoints for axles, boom mounts, and gearbox housings are bolted and welded into place. These structural nodes are engineered to resist bending, torsion, and repeated impacts as the harvester works on steep slopes and in dense stands. By the time the chassis assembly stage completes, the machine has a true skeletal framework, a heavy, resilient platform precisely manufactured to support engines, hydraulics, booms, and the complex harvester head to come. This foundation is what allows the 1470G to withstand the enormous forces of tree harvesting while maintaining operator safety and serviceability. Power and reliability begin in specialized machining centers where the harvester's high-torque diesel engine and transmission components are manufactured. Engine blocks are bored and honed to microscopic tolerances, crankshafts are ground and balanced, camshafts and turbocharger housings are fitted to exacting specifications. Pistons and injection systems are matched to compression profiles for optimum torque at low RPM, critical for pulling heavy loads and driving hydraulic pumps. Meanwhile, the transmission and planetary axle assemblies undergo assembly and rigorous run-in tests. Heavy-duty axles are heat-treated and stress-relieved to manage shock loads, then combined with braking systems designed for steep forest terrain. Powertrain integration has technicians aligning engine mounts, coupling the flywheel to the gearbox and verifying driveline angles to minimize vibration. Hydraulic pump drives and PTO interfaces are installed and dynamically tested on rigs that simulate forest loads, ensuring the pumps maintain flow and pressure without cavitation. Every rotating assembly is run at operational speeds while sensors record vibration, temperature, and oil pressure. Only when data indicates stable operation do components move from the powertrain cell to the final assembly line. This meticulous powertrain work guarantees the 1470G can deliver continuous, dependable torque under the extreme demands of timber harvesting. The boom and hydraulic systems are the harvester's working muscles. Fabrication begins with heavy plate forming and robotic welding to create the articulated boom's main sections. Hydraulic cylinders are precision machined, chromed, and assembled with multi-stage seals rated for high-pressure forestry use. Hydraulic pumps, control valves and accumulators are selected and matched to provide smooth, forceful response under load. Hoses and high-pressure lines are routed through protective sleeves, clamped into vibration-isolated trays, and fitted with quick disconnects for service access. Technicians perform hydrostatic pressure tests that push the system well beyond normal operating range, checking for leaks, seal integrity and thermal stability. Meanwhile, the boom undergoes mechanical trials, articulation angles, reach limits, counterbalance settings and damping characteristics are tuned so the geometry allows precise head positioning while minimizing oscillation. Cylinder mounts and boom pins are fitted with greasable bearings and checked for play. The hydraulic control mapping is calibrated using flow meters and load cells so that joystick input yields predictable movement, essential for the operator cutting and handling large timber. At completion, the boom and hydraulics are bolted to the chassis under controlled alignment, forming a robust, responsive system built for accurate cutting and efficient material handling in the forest. The operator cab is a compact command center designed for safety, comfort and control. Its structural shell begins with a reinforced steel frame engineered to withstand rollovers and falling limbs. Ballistic-grade glass and air filtration seals provide visibility and protection in harsh environments. Inside, ergonomics guide the placement of seats, joysticks and multi-touch displays. Wiring looms are factory assembled into harnesses, labeled and routed through vibration-isolated conduits. CAN bus networks are installed to link engine management, hydraulics, sensors and head control systems. Redundant power distribution and fuse systems provide robustness against electrical faults in remote operations. Cabin climate controls, sound dampening and vibration isolators are fitted to reduce operator fatigue during long shifts. Advanced electronics, onboard telematics, GPS-based positioning, productivity logging and head control algorithms are integrated and bench-tested. Software calibration includes mapping joystick inputs to hydraulic response curves and fine-tuning safety interlocks that prevent overreach or unsafe head angles. Diagnostic ports and service interfaces are validated to ensure quick maintenance. Finally, the cab is mounted on the chassis with anti-vibration mounts and the full control stack is connected, turning the machine from a collection of components into a responsive, operator-driven system ready for field trials.
Initiate.
The harvester head is the cutting heart of the machine, and its fabrication demands exceptional precision. Steel frames are plasma cut and robot welded to form the skeleton that will support feed rollers, delimbing knives, saw units and sensor arrays. Circular saws, often carbide-tipped or with replaceable tooth segments, are balanced dynamically to reduce vibration when spinning at high RPM. Feed rollers and chains are heat-treated for wear resistance and fitted with replaceable sleeves. Delimbing knives are tempered and ground to maintain sharp edges across thousands of cuts. Hydraulic motors that drive the head's feed and cutting functions are matched to torque and RPM requirements, and gearboxes are filled and examined under load. Assemblies are bench-tested in controlled jigs that simulate trunk feeding. Sensors measure grip pressure, roller speed, and cutting torque to optimize feed rates for trunk diameters up to the maximum specified for the 1470G. Signal conditioning and camera or laser-based measurement systems are calibrated to provide real-time girth and orientation data to the head control logic. After final balancing and protective coating, the completed head undergoes full-cycle durability testing, where it repeatedly processes logs under load to ensure long-term reliability before attachment to the boom. Final assembly stitches every subsystem into a working harvester. Engines are mounted, hydraulic lines connected, electrical harnesses secured and the cab fitted in place. Technicians perform integrated system checks, engine startup, hydraulic flow and pressure verification, electronic handshake tests between controllers and diagnostic scans across CAN networks. Load tests examine the machine under simulated forestry conditions, raising a loaded boom, cycling the head, and commanding full traction to the axles. Any anomalous readings are corrected through adjustments and software tuning. Once factory acceptance tests are passed, the harvester is moved to a proving ground for field commissioning. Here, test crews evaluate fuel consumption, traction on slopes, head performance on standing timber, and in-field serviceability. Telemetry captures operational metrics while maintenance teams practice routine servicing tasks. Final safety checks, emissions verification and documentation are completed before the unit receives delivery certification. The John Deere 1470G then leaves the factory as a fully validated machine, ready to harvest timber at scale with the durability, precision, and power engineered through this meticulous manufacturing process.